Standard list, the basic list of the standard template library. Even though it's not in the name, the standard list is always doubly linked. This means that its main benefits are quick insertion and deletion. If you're looking for a specific operation, check in the chapters below. Hi everyone, I decided to explain the standard template library. Over this course we will start from the ground up and cover the complete STL. So if this is interesting to you, stay tuned and subscribe. Today we will cover list, so let's go. Declaring a list is fairly simple. The only thing that we need to do is to include the header, which is called list, and then we use standard list and we use a specific type that we want our list to have and declare this list. Afterwards we can output the list that we have just created. Let's jump to the console and compile this program using Clang, and we see that the result of this program is an empty list. Now let's add some elements to this list. So what we need to do is we use myList, and we can either append at the beginning or at the end. Because it's a doubly linked list, there are two functions exactly for that. So there is push back and push front. So when we use push front, and for instance with the one, it will put the one at the beginning of the list. If we use myList push back, then it will put the element at the end of the list. So after this I expect that I end up with a list which contains 1 and 2, but because the list was empty, the push front doesn't really matter whether it's a push front or a push back. So let's use a third one where we have a push front again. A push front with a 3. So if we compile this program and let it run, we will end up with a list which has 3, 1, 2. And obviously we also need to output it. So let's compile again, and then we end up with exactly this list, which is 3, 1, 2. The same can be done for accessing members or accessing content of the list. We can use the two methods which are called front and back to access elements at the front or the back of the list. So if we now output this one, we will get probably the 3, and if we output the back of the list, we will get here the 2. So let's compile this program and see what it exactly does. If we output it, here we have the list which is 3, 1, 2. myList front gives me the 3 and myList back gives me the 2. Let's now remove some elements of the list. For this, there's also the possibility to remove elements from the front and the back of the list. So we can use myList.popBack or popFront. So if we pop front, it will remove the first element of the list, and if we use popBack, it will remove the last element of the list. So just to show, we will output the list after each of those operations and see what has happened to the list. Let's compile the program, and if we have compiled it, we will afterwards end up only with one element in the list. We see it is still the list 3, 1, 2, and then after using pop front, the 3 is gone, and after using pop back, the 2 is gone as well. There are some more ways to remove elements of a list, so we can really specify which element we want to remove from the list. So let's get rid of this, and here we can use myList.remove, and this now allows us to specify which element we want to remove. So for instance, we can say we want to remove all of the ones that are in the list. So even if we have not only a single one but multiple ones somewhere in the list, remove one will remove all those elements in the list. If we afterwards output this list, and compile the program, we will see that the list doesn't contain any ones anymore. And here we see the list was 3, 1, 2, and now it's 3, 2 because all of the ones have been removed. The last possibility to remove elements from the list is clear. This is my list.clear, and here it's just completely deleting all of the content of the list. So after we have cleared the list, it will be in an empty state directly as after the beginning, after we have just declared it. So let's compile this program, and here we see that after clearing the list is just empty. Let's have a look now at the more specific functions to list. The first one is getting the size of the list. So we can always use my list.size to fetch how many values are currently stored in the list. And we can output this, and because the list has been declared with 479, we will see that this list size will also be 3. So let's compile and see at the output, it's 3 as expected. The next operation is reverse. Since it's a doubly linked list, reversing this list is quite easy and also quite fast. We can just use, for instance, my list2.reverse, and it will reverse the content of the list. So if we output it afterwards, we will get the output 974. So if we compile now this program, we will get the output 974 since the content of this list has been reversed. And we see we get 974 as output of the program. The next really useful function is sorting. So we see that the first list, 132, is not sorted, so the elements are not in ascending order. But we can fix this by calling my list.one sort, and it will automatically sort all of the elements of the list in ascending order depending on the type that you have inserted into the list. So it will use the operator of this specific type to do the sorting of the list. And if we output the list afterwards, my list1, then we will see that it's 1, 2, 3. It's actually sorted. So let's compile and have a look at the output. We see that the my list1 is now 1, 2, 3, so 2 and 3 have been swapped to actually sort this list. If we want to put two lists together, we can use the merge functionality. So we can use my list1 dot merge and merge it, for instance, with my list2, and then the result will be a combination of both of these lists. Merging is only possible if the underlying type, for instance here integer, is the same for both of the lists which needs to be merged. If we now output my list1, then we will see that both of the lists have been merged, and both of the lists, or the list is now 6 elements long and contains all of the values. So we see the list is now 1, 2, 3, 9, 7, 4. Since here we have reversed my list2, and it uses then of course what is currently in my list2. One thing that might come really handy is the unique function. Unique function allows you to remove duplicates from a list. So for instance, if we create another list, so let's call it my list3, and here we have something like 4479, then we have 2 4s after each other. And sometimes you just want to have a list where each element is unique, and this is where you can then call the unique function, and then it will remove all of the elements directly after each other which have the same value. So it will remove those 4s, but it won't remove a 4 that is at this place because they don't come directly after each other. So if we now call it and output it, we expect something like a 4749, but let's compile and double check whether this is actually true, and run the program, and we see here 4749, which then usually is also not what you would expect, or is not what you want to have. So a common usage of the two functions sort and unique is to call sort first and then to call unique after, because then each element truly is only a single time in your list. By using, for instance, here sort first, it will sort the elements and then all fours will come after each other, and then it will remove all of the duplicates that come after each other, which means that we only have every single element exactly once in the complete list. And here we see it's now 479. So this is something that you see quite often in code. But what if I want to access a specific element of a list, so a specific position? For that I need to use an iterator. So I can create my iterator by using something like auto iterator equals mylist1.begin, and then I will have an iterator which points to the first element. And now if I now want it to point through to the second element, I can just increment it once, and now it's pointing to the 3. Now I can use this iterator to either erase an element or to insert an element at exactly this position. So I can use, for instance, my list one.erase, and I pass my iterator, and the good thing is that it will always give me back an iterator as well, since if I erase the specific iterator, the element doesn't exist anymore. So if I point to that element, then this iterator is invalid. But the erase function gives me back the iterator before the element which has been erased. So it will then be an iterator which points to the 1. But let's compile this, or let's output it first by using now mylist1 and compile it, and then we see the result of this. And here we see that the element to which this iterator has been pointing has been deleted, so it was this 3. Now we can use this iterator again to insert at the position, and for this we will use mylist.insert, which allows us to insert specific elements at the position of the iterator. And here we see that it asks us also for the data, obviously, which we want to insert. And here we can use the 3, compile the program, and then we see in the output that we now have 1, 3, 2, because the element that gets inserted will always be inserted after the iterator. So the iterator was pointing to the 1, so it will be inserted after the 1. The main benefit here of the list is that using these iterator operations, none of other iterators are invalidated. So which means that if I have an iterator of the 3, or which is pointing to the element 3, and I erase the first element, then the pointer or the iterator to the position 3 will still be valid, which means that if I'm traversing a list and I'm adding or removing elements on the fly while traversing the list, all of the other iterators are still valid. So this is a big benefit because most of the other containers don't have this functionality, and if you erase a specific element, most of the time all of the other iterators are invalidated by doing that. So what are the benefits of using standard list? So standard list is slow to traverse, so it means that, it's not really a benefit, but it means that each element knows of its next element. It's like a doubly linked list, so it's moving on and on and on, and that's why it's pretty slow to traverse. But this also means that the insertion and the deletion of elements once you are at the right spot is really, really fast. So it's basically in a single operation always done. Additionally, the iterators to elements usually don't get invalidated if you erase or if you insert at specific positions of the list. Additionally, since it's a doubly linked list, it's not continuous in memory. I don't know why it matters. I have never seen it matter in a real programming application that it's not continuous, but it's definitely something worth pointing out. Thanks for joining me today. I hope you have learned something, and as always, happy coding. And if you're still unsure what you want to watch next, I have here a video which I think you will like.